Okay, here we go with 1.5, our last section in chapter 1. So we're going to be rewriting equations and formulas. And you might be thinking, well, why would we do that? Depending on the information you have, it might be easier to have the formula where you have one variable in the formula isolated. Well, let's go ahead and start with these warm-ups. So I want you to find the area of this rectangle, and I'm sure you remember what the formula is for a rectangle. So go ahead and figure that out. And then for number 2, find the circumference. And I've given you the formula there. Circumference equals 2 times pi times r, where r is the radius. So in this case, it's 6. And answer those. Okay, so start with those. Area is equal to length times width. So all you have to do is multiply 4 times 10 and label your answer 40 square inches or inches squared you could put. And here you were supposed to use 3.14 for pi. So multiply all that together and you get 37.68. And is that 100% accurate? The answer is no, because 12 pi would be more accurate, right? If we just multiplied the 2 times the 6. Pi is approximately 3.14, but to be exact, it's 3.14159, and it goes on forever without a pattern. It's called an irrational number. So actually just writing 12 pi would be the exact answer, even though we don't know exactly what pi is. Okay, so our essential questions here would be, how can you use a formula for one measurement to write a formula for a different measurement? And why bother? And again, the reason for that is it makes things simpler. Okay, again, find a partner to work with or your imaginary friend. And here we have a parallelogram. And the formula for the parallelogram is a base times its corresponding height. So it's the height, in other words, the perpendicular segment that comes to a particular base. So for B, substitute the given values into the formula, then solve the equation for B. Okay, so notice here you're given what A is, you're given what the height is. So all you have to do is substitute in. So go ahead and do that. Okay, so plugged in 30 for the A, 5 for the H, and then obviously divide both sides by 5, and you get that the base is 6 inches. Okay, now what they want you to do here in part C is actually solve for B without first substituting values into the formula. So here's our formula, A equals BH. We're not substituting in, and we want to get B by itself. Well, if B is being multiplied by H, what would you need to do to both sides to get B by itself? Hopefully you said divide both sides by H. Those would cancel, right? Any number divided by itself is 1, and that leaves us with 1B. And what's on the other side? A over H. Okay. And then, obviously, we could then plug in, and we'd have 30 divided by 5 and get the same answer. Okay. So compare you solve the equations in parts B and C. What did you notice? After we plugged in here, didn't we divide both sides by 5? Here we didn't plug in, but we still divided by the same thing to both sides, right? So it was similar, right? Because, yes, I don't know why, but just yes. They're similar because we divided the same thing. How are they different? Well, in one we divided by a number, and the other we didn't. So there's no computing. There's no figuring out what 30 divided by 5 was. And what did you think was easier? I don't know. Maybe C? Maybe B? But think about it. If we had a whole bunch of values for A and H, not just one, but like a whole list of them, we had to figure out what the base would be for each of those. Wouldn't it be better to have the equation or the formula in this form? So maybe you'd want to do this, and then you just have to simplify by plugging that in. All right. We've used a lot of this vocabulary already this unit, but I just want to make sure that we're up to up to speed on it all, that we've got it all, and that it's in your notes, so you make sure that you've learned it. So a coefficient is a number multiplied with a variable. So in a term that we have negative 3x, the coefficient's what? Negative 3. Good. A variable term, remember terms are things that are added and subtracted or that stand alone. A term containing a blank would be a variable term. I hope you said variable, oh brother. So example of that would be negative 5xy. Okay. still considered a variable term because it's got at least one variable in it, okay? And this wouldn't be 3 terms, right? Because, again, terms are things that are added or subtracted. So this is like one blob. Think of it that way. Just like negative 3x would be a term. A constant term is a term that only contains a, you got it, a constant. So, for example, negative 89. Negative 89 is a constant. It's not going to change, even if you go to Mars. Okay. Note, a constant is still considered a coefficient. Now, you may be wondering why that is. And let me give you an example. So, let's say I had my constant of my favorite number, which is 5. Okay. Technically, if I put on x to the 0 power here, anything to the 0 power is equal to what? 1, right? So technically, I could still write this with a variable next to it, but it would still be just 5. So and then the 5 would be a coefficient, right? So we could technically consider that to be a coefficient. So even a constant is a coefficient. Okay, well, what do we call terms that have the same variable or variables raised to the same power or powers? Oh, we've used this a lot. Hopefully you're about to say like terms, right? Remember, like terms have the same variable and they're raised to the same power. So if we have like 5x and 3x, we can combine those together and make 8x. If we had 5x and 3x squared, we cannot combine those because even though they both have x's, one's to the first power and the other x is to the second power. Okay, a literal equation is an equation with 2 or more variables in it. So like these formulas here, where area of a parallelogram, the formula for the circumference of a circle, more than one variable in it. Okay, even this one, area equals length times width, 3 variables. So we would call that a literal equation. And a formula is a type of literal equation that relates one variable to one or more other variables. So any kind of formula that we've used, like force equals mass times acceleration, or the perimeter of a rectangle is equal to twice the length plus twice the width. Okay, so how we rewrite a literal equation. Important thing here is don't freak out just because there's lots of letters. This is not hard. In fact, in a lot of ways, and you'll see this, it's easier than having to isolate like a variable when it's the only variable and you have to do the computations. Here you don't have to do that, okay? But we still use the same rules and properties that we learned to solve normal equations. So golden rule of equations still applies. Distributing, simplifying each side separately, all of that still works, okay? So let's go ahead and do this one together. Solve the literal equation 3y plus 4x equals 9, and we're solving it for y. That's why I made it blue there. So again, simplify each side separately. Is there anything that we can simplify on the left side here? No. We've got 2 terms here, 2 variable terms, but they're not like terms, right? Because one has y as a variable, the other has x. What about the right side? No, 9's by itself. Can't simplify that. Okay, what's our next step? We want to isolate the term that's got our variable in it that we're trying to solve for. So that means this positive 4x has got to go bye-bye, right? So what would we do? Subtract 4x from both sides. So if I subtract 4x here, those cancel. And then obviously I can't combine 9 and negative 4x, so I just have to write them like that. Or I could write it as negative 4x plus 9. Okay, if we solve for y, we're getting close, but we're not quite there. We still have to get 1y, which means we're going to divide both sides by 3. And you can see that a couple ways we could write this. We could write it as 9 minus 4x over 3. But since 3 does go into 9, you can go ahead and basically divide each of those terms in the numerator by 3 and write it like this. Okay. Now, if this had been 9 minus 6x over 3, then you definitely want to simplify it down to, what would that be? 3 minus 2x, I guess. Okay? All right. So now go ahead and try doing this one. Solve the literal equation for x. Okay, well, hopefully you saw that if you simplify the right side, those combine and give you 1x. So that means that x equals y. Can you still check these the same way by plugging in? Absolutely. So look what happens if we plug in an x where we had a y here, right? So we end up getting x equals x. Okay. All right. This one's a little trickier. Notice I've given you a hint here. I said factor out the common factor from the two variable terms on the right side of the equation. Factoring is like undistributing. So you remember when you distribute, you basically are getting rid of parentheses. If you're factoring, you may be even like creating parentheses. So watch what we do here. Because we can't combine, and the reason why we have to do this is we can't combine these together. They're not like terms. Yes, they both have an x to the first power, but this one has a z, and that means we can't. Now, if this had been 3xz plus 5xz, then that would have been easy. It would have been 8xz, and we could go from there, but it's not. So let's pull an x out of each of these terms. So what would that look like? Well, it would look like this. Notice that if I pull an x out of this term here, this 3x, what's left? Just the 3. And if I pull an x out of positive 5xz, what's left? Plus 5z. Now, how can you check to make sure you did that right? Well, you could distribute back out, and you should be back to where you started, right? X times 3 is 3x. X times positive 5z is plus 5xz. Okay. Now, we still haven't gotten x by itself, right? So what would we have to do if x is being multiplied by this entire parentheses quantity? Hopefully you're going to say divide both sides by that entire parentheses quantity, right? Those cancel, and I end up with x is equal to y over 3 plus 5z. Now, like I said, you can check this. Now watch what happens when I check this. I'm basically going to plug this in wherever I see an x. So what I've done is I've plugged in 3 plus 5z for y, and then I've got, so I actually plugged it into this step, it looks like. Yeah, I did. And then I have the 3 plus 5z. Those cancel. Y equals y. Check, check. Okay. All right. So try doing this one. Similar type problem. Try doing it. Okay, so I'm going to factor out my common factor for my two terms, which is an x. And then that's being multiplied by 2 plus k. So I'm going to divide both sides by 2 plus k and get m equals 2 plus k. Okay. All right. So here we have the formula for the area of a triangle, 1/2 base times height. And you need to solve for h. Okay. Well, what's going on here with the b and the 1/2 with the h? Hopefully you're thinking that it's all multiplication. So if it's multiplication, we want to use that inverse operation. So what would we do with the b? Well, we would need to divide by b. Okay. And what would we do with the 1/2? We'd want to multiply by the reciprocal. So notice, oh, it looks like I took care of the 1/2 first here. So if I multiplied both sides by 2, right, I'd have, if I multiplied this side by 2, and I multiplied this side by 2, oops, that's an ugly 2, isn't it? Yeah, it is, but it's hard to write with this. Notice what happens here. These cancel, right? And those go away. And we're left with just b times h. And over here we have 2a. And then to solve and get b by itself, what are we going to do? I'll even write it for you. Oh my gosh, how kind. Divide by h, divide by h, and we get 2a over b. Okay? Now let's check this one. I'm going to go ahead and check this one. So we're going to write a equals, okay, 1/2, right? Because that's part of the formula. I'm just rewriting the formula. 1/2. And then b. And then for h, I'm going to put in what? I'm going to put in 2a. Oh my, look at this a. Over b. Right? So all I did was plug that in, right? And I could even put it in parentheses. Doesn't really matter in this case. But now what? What's going to cancel here? B, B, 2, and this denominator of 2. And what do we have left? A equals A. Check, check. How nice is that? So again, really important you check. That's what's going to take you from being good to great. All right. So these are some formulas that you really should know. Hopefully you know most of them, but if you don't, I would definitely, whether it's make flashcards or just study these, make sure that you get it. Okay, so we have two common formulas for temperature, two measures of temperature that are common. Fahrenheit, which is what we tend to use in the United States, and Celsius, which is pretty much everywhere else in the world. There are a few other countries that do use Fahrenheit, and if you look those up and send me an email with that info, I'll give you some extra credit, some homework extra credit. So Celsius is equal to 5/9 times whatever the Fahrenheit minus 32, okay? And for simple interest, this is not where the interest is compounded. So like this would be if you deposited $100 in a bank account and you got 10% interest. So after 1 year, you would get $10. This is not where it compounds, where like the second year you'd be getting 10% interest on $110. It would still just be on 100. That's the difference between simple interest and compound interest. So simple interest, it's just the principal, that's the amount that you invested, times the annual R, the annual interest rate, and usually use a decimal for that, and then time in years. So I equals PRT. And then distance equals rate times time. We've used that. Okay, so here we go. Solve the temperature formula for F. So now we want to solve this for F. So we want to get that F by itself. So first thing we want to do is get this quantity by itself. How would you do that? You need to get that 5/9 off that right side. What would we do? Hopefully you said multiply by 9/5. If I multiply by 9/5, that will cancel the 5/9, and over here I'll multiply by 9/5, I have 9/5 C. And then to solve for F, just add 32, okay? So if you knew what Celsius is, basically double it and add 32. A lot of times what I will do, like if I see a Celsius sign, I saw one the other day when I was driving in Corona Del Mar, actually, and it said 23, no, I think it was 25 degrees Celsius, and I was like, what is that? So what I did was I just doubled it to 50, and instead of adding 32, added 30, and so it was about 80 degrees, which is exactly pretty much what it felt like. It's not an exact way of doing it, but it was pretty close. Okay, so here's another one. Which is the greater surface temperature, Mercury or Venus? And you can see Mercury, you're told, is 420 degrees Celsius. Venus is 864 degrees Fahrenheit. So what are you going to need to do to answer this question? Yeah, you're going to need to convert either Mercury Celsius into Fahrenheit or Venus Fahrenheit into Celsius. And since we're given the formula in this state, probably we want to do what? We probably want to just plug in F over here for Venus and figure out what it is in Celsius. So if you did that, what would you do next? Follow order of operations. You would, subtract the 32, and then we would multiply 5/9 times 832, and you get 462.2. So which one's warmer? You said Venus. You were right. I think it has to do with the fact that it's got kind of more of a greenhouse effect with its atmosphere, whereas Mercury is a very thin atmosphere. Okay, now we're going to use that interest equals P times R times T. Okay. You deposit $5,000 in an account that earns simple interest. After 6 months, the account earns $162.50 in interest. What is the annual interest rate? So again, probably want to write the formula to start with, just to remind you what it is, right? And then what do we have? Let's see, we have 5,000, which is the principal. 6 months, right? So the time there is 6 months. And we know I is 162.5. So we're trying to solve for R here, right? So notice what I did. I went ahead and just, isolated r first, and then all I have to do is plug in, and it's like just simplifying aside. So 162.5 goes in, 5,000 goes in, and notice the 0.5 or 1/2, right? Why is that? Right, because it's only 6 months. Okay. And then we just got to simplify that. So different ways you can do it, but 5,000, half of 5,000 is 2,500. Divide that into 162 and you get 0.065. So that's going to be the annual interest rate. What would that be in percentage? Yep, move the decimal place over 2 spots. Some people call that doing the butt. That's what one of the lower school teachers used to call it. I don't think any of you had Miss Hardesty. I think she's been gone long enough. But anyway, see how it makes like doing the butt? Anyway, 6.5%. Okay. Cool. And let's finish with this one. So this is going to involve distance equals rate times time. This one's a little bit more complicated, so you really have to kind of think about this and break it down. Again, remember, use those strategies. Hello, Mr. or Ms. Word Problem. I'm going to solve you now. Okay, a truck driver averages 60 miles per hour while delivering freight to a customer. And by the way, the other way is happy place, and I'm pretty much in my happy place right now. I don't know if you could hear that seagull in the background, but I'm sitting on a big terrace down in Torrey Pines enjoying my 25th wedding anniversary with my lovely wife. And when I finish with this, we're going to go sit out on there and look at the beautiful golf course below us and the ocean in the background and the sunny skies. Perfect, perfect spot. So I'm in a happy place. So I'm relaxed. I'm going to be able to solve this word problem. Okay. So a truck driver averages 60 miles per hour while delivering freight to a customer. On the return trip, the driver averages 50 miles per hour due to construction. The total driving time, so for both directions total, 6.6 hours. How long does each trip take? So we know they add up to 6.5. And I know distance equals rate times time. Okay, so what am I solving for here? We know the total driving time, and we know the rate, right? So what we don't know is total time, right? We do know total time, sorry, 6.5. But we know that's made up of what? The time for the delivery trip and the time for the return trip. So what you want to do is say, okay, the time for the delivery is equal to d over r, right? How did I get that? I divided both sides by r. Right up here, I divided by r. Here I divided by r, and those canceled, right? So I get t is equal to d over r, and I just flip the sides, okay? So what is it, the time for the delivery trip? It would be what? The distance, which we don't know, over the rate, which we do know was 60, right? So we could write that as d over 60. Plus the return time would be, again, distance we don't know over the time, which is what? I'm sorry, over the rate, which is 50, right? And what is that going to equal? The total driving time, which we know is 6.6 hours. Okay, so now we need to solve this. We've got like terms here, don't we? We have d to the first, d to the first. In order to add these fractions, what do you have to have? Hopefully you said a common denominator. So 300 is a common denominator, right? What did I multiply this fraction by? 5 over 5, right? So I get 5d over 300, and this one by 6 over 6. I get 6d over 300. So what would these combine to get us? Remember, if you add fractions, you don't add the denominators. So you have 11d over 300. Think of it, if I had half a pizza and you had half a pizza, and we put our halves together, what would we have? We wouldn't have 2/4 of a pizza. That would still be a half, right? We would have a half plus a half is 2 halves, or a whole. Okay, and then what would we do to solve for d now? If it's 11 over 300 times d, you would multiply by the reciprocal. So we would multiply both sides by 300 over 11, or I've kind of split it up into two steps. So first what I did was I multiply both sides by 300. So if I put a 300 here, those would cancel. I'd be left with 11d. and then 6.6 times 300. And then what? Then I would divide by 11. Now I could, like I said, I could have multiplied just by the reciprocal of 300 of 11 and kind of done it all in one step. Okay. And so then D equals 180, right? Does that answer the question? If we answer the question of how long does each trip take? No, we haven't. What we have done is we figured out what the distance was. Okay, well, now we have to do that, right? So where would we go to figure that out? Well, we go back to here. We know the distance is 180. So the delivery trip, if I'm going 60 miles per hour and I need to go 180 miles, it's 180 divided by 60, which is 3 hours. And for the return, it would just be 180 divided by 50, plugging into that. And that is 3.6 hours. Does that make sense? Why does that make sense? Yeah, 3 plus 3.6 is 6.6. And there you have it. All right, so that's the end of the instruction for Chapter 1. Congratulations on that. And so we'll jump into the homework on this and the practice work, and then we'll get ready to probably take a quiz and a test. All right, congrats.